Hello and welcome to the .NET user group of Pittsburgh. Where is that screen? We put up the .NET Foundation here based out of Pittsburgh. You can join to the meetup with PGHDOTNET or LinkedIn. You can follow us and Twitter as well. So today's topic is blood, sweat, and code reviews. We are delighted to have David here for us to hear during the next hour. We will also hear from the expert and his knowledge, and he has been working in Microsoft technology stack for almost 3 decades. He also works as a partner solution architect at Microsoft. And let me pass it back to Dave. Hey, Dave, welcome.
Thank you. It's good to be here. Better.
Thank you. And here we go.
Is it my turn?
Yes, your turn.
Excellent. Let's talk about code reviews. I'm going to talk about what they are, why they're important, and why some people don't use them, and how we can maybe make them better and either encourage people to use them that aren't using them or make a better process for those who are using them. My name is David. I work for Microsoft. My job is to help partners build applications on Microsoft Azure. Yeah. If you want to follow me online, you can go to my website right there, my blog, and I write about a lot of things. I publish a lot of videos online, some of them on this topic, actually. My slides are locked up. What is going on? Go back, go forward. I can go backwards. Doesn't like me going forwards. How about if I click over here? There, that's better. This is Jack. Jack is a software developer. Jack spent days writing a software component. He tested it, he double-checked it, and then he checked in his code when he was satisfied that it was working properly, according to the requirements that he was given. So he checked it into source control. It went into production a few weeks later, and then it was released. A new version of the software was released to the public. An end user, discovered a problem with the code, a bug with the code. It was an edge case, one that he hadn't really tested for, and they tweeted about it. And so word got around that there was a bug in this code, got back to Jack's boss. Boss told Jack, he fixed the code, made the correction, checked in his updated, fixed code. That went into production, problem solved. A few weeks later. This is Joe. Joe is a software developer, and Joe spent days writing a software component, which he tested and he double-checked before he was satisfied that it worked according to the requirements he was given. He checked it into source control. It went into production, and a few weeks later, a new release of the software went out. But before it went out, a tester looked at it. Another set of eyes looked at it, and they tested for some things that Joe didn't test for. And they found this edge case, and they let him know about it. They sent him some feedback. And so Joe said, thanks for that feedback. He fixed it, checked in the fix, and then a few weeks later, it went into production, and no bug was found. So the same results for Joe and for Jack, but Joe's correction happened sooner, and it happened with less embarrassment due to this code review process that was in place at Joe's company. That's what we're going to talk about today, this code review process. We'll talk about some of the basics, maybe a few definitions. Why do we do code reviews? I just showed you an example of one reason. And then some challenges of it, maybe some reasons why they're difficult, and maybe reasons why some people don't do them. We'll talk about the various parties involved. The two major parties are the code reviewer, the person is the gatekeeper watching, checking to make sure the code is good enough, and the code author, the person that's writing the code and ultimately responsible for making any corrections. But there's a third party involved, and that's the manager. And I'll talk a little bit about the role that they play in this process. And finally, I'll show you some links that you can do. There are a few links scattered throughout this slide deck, but I will, at the end of it, give you a link to the deck itself. So if you see a link, you don't have to write down really quickly before I advance. Just I'll pause on that one link with the slide deck on it. You can grab that. All right, some of the basics. I'll start with some definitions. These are words that you'll hear referred to in a code review process. A change set, that's the set of changes that somebody makes and submits for change. So if I'm writing code, it might be a new feature, a brand new component, or it may be changes to an existing component. Those code changes themselves, those are the change set. Change list is related to that. That is the documentation of that change set, a list of describing what those changes were. I say this because some people use those words interchangeably. Sometimes I do, but they're not exactly the same thing. Change list describes the change set. A pull request is a request to merge code with the main branch. So typically what will happen is I'll write code, and rather than checking into the main branch where it can go into production, I'll check it into some other branch, and I'll say, here's some code that I request to get pulled into the main branch. And that's called a pull request. Before that happens in a code review, there's somebody that vets that process. That's the code reviewer. Code reviewer is the gatekeeper. Their job is to check the code, validate it, vet it, and decide thumbs up, yes, this is good enough to get merged with the main branch, or no, it's not good enough yet. It's not ready yet. There are some things that need to be addressed before it can be merged with the main branch. The code author is, of course, the person that's authoring the code, and if there are corrections that need to be made, the code reviewer finds, then the code author is responsible for making those changes, or at least addressing those changes, like telling them it's not a bug, it's a feature, which might be a valid response. And this might be reviewed for some of you folks here, but this is the whole code review process. I'm going to show it because I spent a lot of time on these PowerPoint animations. But essentially what happens is the code author will make changes, that's the change set, and they will submit those changes along with a change list to the code reviewer. The code reviewer then will review the code, review that, look at the change list, review the change set, run the code, make sure it all works properly, does what it's supposed to do, finds any potential problems. And if there are any issues, the code reviewer will document those issues and send them back to the code author. The code author will then address each issue, probably put a comment next to each one to say, I've fixed this, or this is actually by design, look at the documents, or this is ambiguous, let's talk about it. And then send it back to the code reviewer. And this ping pong might take place multiple times until the code reviewer says, thumbs up. This is ready to go. I approve this change set, at which point these changes can be merged in with the main branch. All right, why do we do this? Well, the first thing is just to validate the code to make sure that it's working well, but we do some other reasons here. I'm not going to drain this slide here because I'll describe in detail each one of these things. So let's start with validation of code. The most obvious reason to review code is just to make sure that it does what it's supposed to do. You probably have a set of requirements, and somebody has coded based on those requirements. Maybe it's a bug that's been entered into the system. Maybe it's a new feature request, and there's a design document for it. Whatever, validate in that the code does what it's supposed to do. Given these inputs, it'll produce those outputs, for example. But we also want to validate the code from an internal point of view. For example, if our team has coding standards, then we'll want to, come on, there we go. We'll want to test to make sure that it adheres to those standards. Are there potential problems? That maybe it runs but doesn't run quite fast enough. Maybe there's a more efficient way of doing it. Maybe it uses a lot of memory. Maybe it's hard to maintain. There are areas of improvement that even if it does everything that you've asked it to do, maybe there are some ways that it can be improved. So they're testing for those things as well. Another good reason for doing code review is this idea of sharing knowledge. If I've written code and you are reviewing that code, that means we both are looking at the same piece of code. We've got one more person that has had eyes on the code, and they have a little bit more understanding of what the code does. And that can be the business rule, understanding the business rules that went into that code. It could be the code itself. making sure they understand that. Could be the technologies involved. Maybe you're using some libraries or using some patterns and things like that. You're educating each other on this and sharing that knowledge. And this is important because you probably know this already, but every software developer has a bus and a lottery ticket assigned to them. And I've been in many, many meetings where either the bus or the lottery ticket came up and said, what are we going to do if Dave gets hit by the bus? Or what are we going to do if Dave wins the lottery? And in either case, Dave's not going to be here tomorrow. He's either going to be in the hospital for months because of the bus, or he's going to be on an island somewhere sipping margaritas because of the lottery ticket. In any case, are we going to lose all of the knowledge that was inside of Dave's head? Well, maybe, but if there's somebody else looking at the code, then we've disseminated that knowledge among our teammates. Another good thing is to making engineering decisions. We have a set of eyes looking at here. We can improve our standardization, remove confusion, remove inconsistencies. Sometimes looking at code raises questions. We never really thought about how we're going to, consistently access data. And maybe we'll take a step back and say, this is how we ought to be doing there. I've looked at several different pieces of code and they're doing the same thing in different ways. Maybe we have multiple libraries doing the same things. Maybe we're not using the same coding standards. So the engineering decisions can evolve from a different set of eyes looking at the code. It's a big advantage to this. Addressing weaknesses in the code. Of course, we want to address weaknesses in the code itself. If we find a bug, we want to have them fix that bug, but also weaknesses in developers. This is a great example of us learning from each other. A code reviewer can point out something that maybe the code author didn't know about. Hey, here's a pattern. Here's a library. Here's a different way of doing things. Here's a principle that you should think about, and they can educate each other on that. Similarly, the code reviewer may look at the code and see some clever things that the author is doing, and because very often code authors reviewers are also developers that can improve their skills as well. Maintaining consistency. I talked about this before, and educating each other. Consistency can be things like the naming conventions, the libraries that are being used, the algorithms that you're using, the size of your project, the separation of the project, the folder structures of their project, the sizes of the classes and the methods, what kind of rules we have on documenting our code. Should we have these triple slash comments at the top of every class, at the top of every method? Should we have comments inline? These kinds of standards. Whether we're using tabs versus spaces, that's a kind of becomes almost a religious argument sometimes. But if we have people looking at the code, then we can start sparking those conversations, see where the inconsistencies arise. And consistent code is really useful on a team because it allows other developers to step in and start using somebody else's code immediately. If that lottery ticket or that bus comes around, or maybe just somebody goes on vacation for a few days and somebody else needs to come in and fix a bug real quick on code they didn't write, having consistency among the way you're writing code is a huge advantage in those scenarios. Of course, compliance can be a big issue. I've worked in some organizations. I did some work for some government agencies, and they require code reviews. That's not even a question. We had to prove to them that we were doing code reviews. There are also things like CMMI maturity levels and ISO certifications. If you want to get those, then you have to have a review process in place just to meet those requirements. I would suggest that there are reasons for doing it even without, if it isn't being required by some outside body, but that's out there. So some of the long-term benefits of code review. One of the big ones is you're going to catch problems sooner, which leads to shorter rework time, less embarrassment, fewer support calls from your customers, fewer issues downstream. And we saw this with the Jack and the Joe example. Joe's error was caught sooner, and he was able to fix it really quickly. There was no embarrassment that it went out and somebody tweeted about it. And there's a principle in this called the shift left principle. The idea behind the shift left principle is that the sooner you can fix a problem, the cheaper it will be. So if I fix if I'm writing a line of code and I notice that I've made a mistake on the line before it, and I just backspace and fix that right away, that might cost pennies to fix that. If it's caught during a code review process, that might cost a few dollars, or if it's caught during my integration test, that might cost a few dollars. But if it's caught when it goes into production, then things can get, or further down, even further down in some of the user acceptance testing. The further right you go, then the cost goes up exponentially. Here's a example. If you go to that link there, you can find details on that. But if you find it while you're pair programming, it's almost nothing, or during continuous integration, it's almost nothing. It starts to get expensive if you find it during a review, your traditional system test them, acceptance testing, and not shown on here is if it goes out into production and somebody else to do it. There's a lot of reasons why that's true. One is one significant one is that if the code author doesn't get the problem addressed or sent to them until weeks later, the code's no longer fresh in their mind, and they have to remember everything that they were doing, everything went into that code, which is a challenge for any software developer. And they may be actually working on something else. They may have moved on to the system, either that system, they made changes that they now have to shelve to go back and say, let's work on the system as it worked, find the bug that was there 3 weeks ago. Anyway, there's a lot of reasons why, but the bottom line is that as we wait, the longer we wait on this curve to find a bug that we need to fix, the more expensive it becomes. And when we say more expensive, I mean exponentially more expensive. There's been a lot of research done to this. All right, so I think, given all this, we can all agree that code reviews are awesome. We should all be doing code reviews. I'm not sure how many of you are doing code reviews, but but not everybody is. I've been my experience. I was a consultant for many years. There's lots of folks that that's just not part of their process. And there's reasons why. Let's talk about some of those. Here's a list of them, but I'm going to go talk about one at a time. The big one, so here, one thing, so I'll talk first about this. There are multiple parties involved. There's the reviewer and there's the author. So I'll talk about the code reviewer first. Like, one thing is that being a code reviewer, you're pointing out errors in somebody else's code. And for some of us, that feels unnatural. It feels like we're being rude if we are telling somebody, there's a problem with your code. I mean, who am I? You wrote the code. Who am I to criticize your code? And for some of us, that just feels unnatural because I wasn't part of the discovery process. I'm just finding things afterwards. The other thing is that it does interrupt. It does take time. It does take effort. It's going to interrupt my workflow. And I have to set things aside and that I'm doing right now. As I said, a lot of code reviewers are also code authors. I think that's a good practice, but we need to commit that time and get that energy. Not everybody, we certainly don't have unlimited amounts of time and energy. For the code author, one of the big things can be that we feel like we identify with our code. We take ownership of our code. We take pride in our code, and that's good. That's a good thing. But what we don't want to do is to confuse criticism of the code with criticism of ourselves. Don't take those criticisms personally. So that can be a problem here. If we don't change our mindset and say, okay, this is talking about the code. It's not talking about me. I'm still a good human being. I'm still a child of God, a special snowflake. There just happens to be something that I can improve in my code. Take that attitude. That's better. That's a challenge. The other thing is that I have been in organizations where they count bugs and they count those against you. So if the review process raises some issues, then the manager is going to see those. And so that fosters a mindset where developers are pushing back and saying, wait, that's not a bug. And they'll defend that. Rather than addressing it and fixing it, it becomes an adversarial relationship. All right, so those are some of the challenges here. They're valid ones. Certainly this idea that it takes time is a really valid one. But we can improve that. We can address these things. And I'm going to show you a few ways where we can make the code better. All right, we'll start with the code reviewer. How can the code reviewer make this process better? Number one, don't delay. Once you get a pull request, you get a change set, you get a change list, take, as soon as possible, start working on this. Now, the sooner you can get it, start on it, the sooner you can get feedback to the code author, the sooner they can start working on it, and you're shifting left even further. Now, I understand that it's not always possible. You can't just drop everything. You've got other responsibilities. But think about that. Think about that priority, that the longer you delay, the harder it's going to be to get that feedback. The sooner you can do that, the fresher in mind of the code author this feedback is going to be, the faster it's going to get done. If you end up waiting a week before you start it, then things are going to be a lot more difficult. So this is one thing that can really improve that. Use the computer for the things the computer is good at. That means pulling the source code down to your local computer, compiling it, running any automated tests. If you have linters, run those. There are tools for testing things like white space and naming conventions and unused imports and things like that. There's a whole bunch of styling tools that are available to you, things like the .NET code formatter or the JavaScript standard style, things like that. Use the computer for those. Don't waste your time doing things that the computer can do better and faster than you can. So start with that. Always start with that. And if it fails that, if it fails anything that's automated, like it fails some of these automated tests, just stop right there. Don't even bother with anything else. Send it back right away. They have to do that. They should have tested, make sure it compiled, make sure that they've checked in all the dependencies, and shift left. Create a style guide ahead of time. There's no sense in wasting time arguing over naming conventions, whether tabs or spaces are better. These things should be done up front. So that's not the job of the author and the reviewer to debate over this. This should be documented somewhere, should be published somewhere in your system. Everyone should have access to it. They should know it. You can create your own if you want to, but I would recommend starting with one like this one right here. Google has created one. It's actually a huge one because it covers a lot of different languages. And so what I've done is I've taken that one, saved it to my local drive, and then just deleted everything that wasn't relevant, and then looked through it and said, oh, you know what, we can modify with that. But it's a huge time saver to start with this. And then I recognize that it does evolve over time. There are maybe things that you don't address in this style guide that come up and there are debates, and it may be a chance for you to go back and look at it. But having a style guide will speed up this whole process and resolve a lot of arguments ahead of time. This is a good one here. If you start with the high level to the low level, then a lot of times if you're doing things like looking at the architecture, looking at the way that the classes interact with each other and how the methods call one another, and you see issues with that, sometimes when you're addressing those, the small details, the spelling errors, the broken connection strings, those things will work themselves out as you resolve high-level issues. It's almost never true if you're down in the single individual lines of code and you're starting to correct those, that the high-level stuff is going to work itself out. So always start at a high level, looking at the way the components interact with each other, and then move to the low level. It'll be a lot more efficient that way. Including code samples in your review process. This is a way of communicating, because it's very possible that what you're suggesting the author wasn't aware of. If you're telling them to use a certain pattern or using certain libraries, then a bit of pseudocode doesn't have to be, you don't have to rewrite the code for them, but point them to a blog post that describes this. Write a bit of pseudocode in your comments to show what they're going to do. I wouldn't do a whole lot of this. You don't want to do their job for you. I would reserve this mostly for things that would be reduce the amount of lines of code, for example, to make the code more efficient, something like that. There's a question like, how can you go with code examples without rewriting it for them? And there's a couple of ways. You can point, you say, how far can you go? And I would suggest just a bit of pseudocode or pointing to a blog post that has examples of the code that you're doing. This is what you can do. Be generous with those code examples. You don't want to do the author's job for them. That's part of it. Part of it is that it's not the job of a reviewer to do that, but you do want to give them a little hint in the right direction. And then this is a big one here. I said earlier that sometimes we tend to take criticism our code personally. We think that it's criticism enough. You as the reviewer, you have a responsibility to try not to make it personal. For example, don't use the word you as in your comments. Let's say you should have done this. You returned the wrong value. It should be this method should return this when in fact it returns that. So make it about the code. Don't make it about the developer in your comments. The other thing is that you can rephrasing things as requests rather than commands. Consider doing this rather than saying do this is a good way to phrase it. You don't want to be vague about what the issue is, but you can be more polite about that. And then finally, express principles, not opinions. What I mean by that is that if you say this class is too long, break it up into 2 or 3 classes, that sounds like an opinion. But if you say this class does these three things, which violates the single responsibility principle and should be three different classes. Now you're debating, the only opinion you're stating is that you agree that the single responsibility principle is good. And I think most people would accept that. So rather than having opening up an argument to saying this is my opinion, point to a specific principle that you're defending. I see a comment using Copilot or AI. So GitHub Copilot is a great automated tool that'll help with a lot of these things. This is something, as I was creating this talk, that I had never really thought of before. I read an article. This is the article down here. As I said, I'll give you like the slide deck. But it suggested use prefacing your review comments with labels to say exactly what they are. And they suggested these were issue, suggestion, question, nit, chore, thought, praise. And this is issue is a problem that needs to be addressed. Suggestion is a potential issue, but maybe it doesn't have to be addressed. Just something to consider. You might want to do this. A question may or may not be a problem. I just want to know, in this example, why did you choose this type of class rather than that type of class? I would have chosen this one, but maybe there's a good reason for it. Just answer my question. That's all. You may not have to change the code if you have a valid answer to that question. A nit is something that that'll take 2 seconds to fix, and I recognize that it's a silly thing. Maybe you spelled something wrong, or you've got a better name for a method, something like that. You should fix it, but I'm almost embarrassed to bring it up because it's such a simple thing. A chore is something that takes longer. It has to get done, and it's just rote work. A good common one: remove unused import statements or change tabs to spaces. I don't know, something like that. That might take a long time. A thought doesn't have to be addressed at all. It's just an idea. I'm just trying to educate you on this. Maybe you're doing something one way, and I've worked on similar code. I can do something else. Maybe there's an open source library that will replace all this extra code that you've written. We can simplify it by just calling that open source library or a commercial library that we already own. Just something that you want to. It's not going to block the review process, but it's an idea that I want to do that. And then this last one, it had never really occurred to me. I've always thought of code reviews as a vetting process. Let me know only if there's a problem with the code. But a code review process is a great place to send praise, to tell someone that when they did something right, and to be specific about that. Say, hey, you refactor this thing. That was a great idea. This is much better than it was before. And I just love that idea. And speaking of praise, don't just say good code. don't be generic about your praise. Be specific about it. Don't include praise unless you have something to specifically say. This particular method is running much faster. It is way better. It is much more readable. Therefore, it is much better. This thing you did, this specific thing you did, improved it. All right. This is another one. Consider the scope of the review. There's a temptation as you're reviewing code to kind of poke around and find things outside of the change set that maybe you can review. That'll just delay the process. As much as possible, you should be focused on the change set and the change list that were submitted to you in this pull request. Now, there are exceptions to this. For example, if it's a really trivial thing, somebody's you happen to notice that the line above it has a misspelling error, it'll take them 2 seconds to change that. That's okay. You can do it that end. Or sometimes there is a change in one part of the code that affects another part of the code. So for example, maybe you change the body of a method and now it does something different, and the name of the method should be changed to reflect this new thing that it does. So there are a few exceptions, but generally, by and large, review only those things that are part of this particular change set. Confirm your assumptions. It may be that the code is slower than you like, but maybe speed is not important to the application. Maybe it's not. Maybe it's a batch process that runs on overnight. Just confirm that. Problems, a lot of times, they depend upon context, and just understand that what you see is an issue is in fact an issue. And then stalemates. This is an issue in any code review process. This is when this ping pong process between the reviewer and the author just goes on for too long and no progress is being made. It's perfectly acceptable when the reviewer sends something back and you say, this actually isn't a problem, this is working as designed, and sending it back, but sometimes the reviewer and the author would simply disagree on whether or not this issue needs to be resolved, and that just leads to no progress, tension between the reviewer and the author, and just nothing else is getting done. It's a real problem. How do we address this? Well, here's some ways to address it, and they're in order of which you should try them. First thing is to talk about it, because oftentimes a code review process is done through written communication. We have tools like GitHub and Azure DevOps that facilitate this process. And written communication is imperfect. We don't see facial expressions. We don't see tone of voice. Sometimes it makes sense just to walk over to someone's desk, get on a Teams call or a Zoom call, and actually just talk to them and say, hey, let's hash this out. Here's what I see. Here's why. And sometimes that'll help a lot. Just that interpersonal communication, verbal communication, face-to-face is awesome. If that doesn't work, maybe there's a problem in the architecture. You need to go to do a design review. You need to go into a room or a virtual room and get a whiteboard and say, hey, we differ on this, but this should have been hashed out before we began the design. Let's make a decision and actually design this thing to address the thing that's blocking us. And then next thing is consider conceding. Consider saying, you know what? I know that I'm right, and I know that I'm more right than you are, but there's very little dogma in software development. That's the thing, is that we can both be right. We can have different solutions to the same problem, and often that's okay. And it may be, again, I might think that, yeah, your solution is right, but mine's way more right than yours. But think about, okay, if I concede and I just do it their way, what are the consequences of that? Our puppy's going to die if I do this. What's going to happen if I concede and just hand it over to them and just approve this anyway? Is the system going to crash and burn? Is it a fatal flaw, or is it just going to be slightly less efficient? And sometimes conceding is okay, because it's better than blocking this thing for weeks at a time. And then finally, the last resort, escalated, bringing up to the architect, the project manager, the product owner, whoever is the team manager, whoever's in charge of that, and let them make a decision. And I would do this in order. Discuss with it face-to-face, review the architecture, concede, and if each one of these, if they work, great. If they don't work, go to the next step. The last step is to involve the boss and say, hey, you know what? Here's my argument. Here's their argument. There we go. Somebody said we could call a vote of other people's opinions. There you go. All right. Here's something to consider, that the goal of any review process is to improve the code. And when I say improve the code, that doesn't mean that it has to be perfect. And sometimes what happens is that there's when you get a large change set and has a lot of problems in it, there's a temptation to not approve it until every single problem is addressed. And that isn't always necessary. Sometimes you can let code in that has some trivial, non-fatal problems with it. The best way I've heard this described is that if you assigned a letter grade to a code, you want to always improve it one letter grade. So maybe you get code that's not very well done. It's a C-, get it up to a B-, make it better than it was before, and then ask them to address in the next change set. Maybe create some new things in your application lifecycle management system to add some more corrections to it. But it might not be necessary to hold up these pull request merge until every single issue has been resolved. Bringing up one letter grade is sometimes enough. Here's just a efficiency thing. Avoid repeating feedback. Sometimes this isn't that uncommon. You'll see the same issue over and over again in the same code base. You don't have to type out your comments over and over again. Just see this comment above. Just an efficiency thing. Slow down. What I mean by this is that when you're reviewing code, one, give it your full attention, block out everything else, make this the focus of what you're doing. Don't rush through it. And I would recommend not reviewing more than 500 lines of code at a time, or spending more than 60 minutes at a time reviewing code. If it's longer, if you're spending longer than that, that's probably an indication that the code reviews or the change sets are too large. They probably should be smaller, but you as the reviewer, you often don't have control over that. And you want to be able to give this, your attention, to actually be present and focused on this. And slowing down is a good way to do that. Just breaking it up and saying after 500 lines or 60 minutes, those are rather arbitrary numbers, but just take a break and then come back to it later on, just to keep yourself fresh. Communicate clearly. This is something that a lot of software developers, a lot of technical people struggle with, is communication. We went to school to study computer science or whatever. We went to school to study some science, and we didn't learn. I think colleges don't do a great job of teaching communication skills in technical majors. But that doesn't mean you can't learn it. You can't get better at it. And so communicating clearly, this is something like Copilot or ChatGPT could be really good at this, is if you're struggling with communicating what the issues are, they can use that to improve it, to be more concise, to be more clear in what you're doing. So it is written communication typically, and it's hard. It's hard enough without being vague or being ambiguous in what you want to do. All right, so this is just a summary slide of what I just talked about for the reviewer, the high level to low level. Consider the goals and the scope of what you're doing, and don't make it personal. Maybe I ought to put that one first. Don't make it personal. Just think about, what you're doing here is you're not critiquing the person, you're critiquing the code, and your communication should be all about that. All right, so the other person involved in this is the code author. What can they do to make code reviews more productive? There's a bunch of stuff here. Number one is your mother doesn't live in your code. You've got to clean it up yourself. Review your code first before you do anything else. Make sure, think about it from the perspective of a code reviewer. Look for things that they might do. So before you submit a pull request, take a step back, look at your change set, look at your change list, and just confirm that it does what it's supposed to do. Test it, do manual tests, run any automated tests that you have, do all this thing. This could be unit tests or integration tests, end-to-end tests. Correct those issues before you submit the pull request. Just like the reviewer should be using the computer, the code author should be using the computer. These are tools like automated testing harnesses, linters. Of course, you want to compile the code and make sure it works. Using tools like GitHub Copilot can help with this as well. Write a good summary. Don't make them guess about what they're doing. You're creating a change list, then communicate explicitly what changed and why it changed and which issues you're addressing, which bugs you're fixing, what the expected output is going to be. That'll make the code review process go a lot more efficiently. And then communicate that clearly to them. This is not only in terms of the change set, but also in terms of the feedback. So when they get something back, then if they send back a list of issues, you want to be as clear and concise as, okay, I've fixed this. This is what I've changed. This is what you should see now. Or if you're challenging it, say, this is why I think this is by design, and communicate this. We're not all great at that, at written communication, but we can all get better at it. And there are tools out there, ChatGPT and Copilot are really good ones for that can help us to improve our communication. So if you feel like that's an area that you need help in, lean on a tool and get better at it. I strongly recommend, there's a really good book called The Elements of Style by Strunk and White. The book is about 75 years old, but it's been updated about every 10 years. And it's just a really book about 70 pages long that talks about clear, concise communication. And I reread it about every 5 years. And it's really improved my written communication skills. And it was written by E.B. White, who wrote Charlotte's Web. So it's good. All right, I kind of alluded to this in the code reviewer section, that if code reviews get to be too big, then they become hard to focus on. The real feel need to split it up into multiple sessions. You as the author, you want to think about keeping your change sets small, probably less than 400 lines of code. If it gets bigger than that, that's an indication you probably should be splitting this up into multiple change sets. And one way to do that is to focus each change set just on one thing. So you're not fixing 10 different bugs or adding 5 different features into a single change set. Splitting them up, it'll make the entire code review process a lot faster, and you'll get that feedback. You'll shift everything left when you do this. So narrowing the focus of your change. I guess I said this already. Only one feature or one bug, or maybe just a couple of bugs, they're tiny ones. Just narrow the focus of it as you're doing this. Another way is to separate functional and non-functional changes. So if you're doing something just changing naming conventions or the indentation, then make that its own change set, its own pull request. Separate that from when you're fixing a bug or adding features. Those should be two separate things. One of the canonical examples, if you're doing indentations, maybe changing tabs to spaces or going from 2-space indentation to 4-space indentation, it's a simple thing to do, but it's going to change every line of code. And there are tools in most DevOps solutions that will do code comparison. And if every line of code changes, then it's impossible for anyone to say, okay, which lines of code actually affected the functional changes here. That's another good reason why you should separate the functional and the non-functional. So if all you're doing is refactoring, that can be a non-functional change. But if you're actually adding a feature or fixing a bug, that is a functional change. And keep cool. Respond graciously. Maybe the code reviewer never saw this presentation, and they're not being polite, and they are saying you when they really should be saying the code. Respond graciously. Understand that they're not talking about you, even if it sounds like they are. They are talking about the code, and make sure they're on the same side as you are. Their goal is to improve the code. Your goal is to improve the code. And this can be a challenge because sometimes the reviewer is just mistaken. They just say something that this is a problem, and maybe they don't understand the code or they don't understand the requirements. Even in those cases, you want to be patient if the reviewer is mistaken. And one of the good reasons is because if they're mistaken, that might be an indication that your code isn't clear enough. Maybe it isn't as readable as it could be. Maybe the method names could be a little bit more self-documenting, or maybe your / comments at the top could be more clear. So that might be an opportunity for you to improve your code, even if you know what they said is wrong. There may be something in there that can help you out and help the code out. And so doing that, refactoring your code to make it more readable, eliminate any confusion. This is a really good way to remove that ambiguity and remove that possibility of this of a reviewer misunderstanding what you've written. Respond quickly, just like the code. The code reviewer should respond quickly. The code author, if they get a list of issues back, the sooner that you can get to them and address those issues, the sooner that we can get through this process. They can review it again and hopefully merge it into the code, but they may have some issues. There's some more issues that they're going to send back to you. We want to shift this to left as much as possible. And just like with the reviewer, the code author has other things. They can't always just drop everything and immediately respond. But all I'm saying here is understand that this is a priority. This is something, the faster you respond, the better this process is going to be because of this shift left principle. Just reducing the amount of lag between these rounds of review will help everyone. This is something that I've read for a couple places. If you come up with a tie, you both just agree to disagree, it might be a good idea for the author just to concede and say, as a general rule, if we're both right, I'll just make the change, which often is a lot faster than arguing about whether the change needs to be made. So consider that. All right, so this is a summary of this section here. The key points: review your code first. Make sure that you're not checking in code that doesn't compile or that has problems. So find those obvious things first. Keep your change sets small and focused. Keep your code readable. Communicate clearly, and don't take it personally. Understand that no matter how it's being phrased to you, this is not about you. This is about the code that you've written. You probably noticed that there are some things that actually appeared in both sets here. Keeping this review time short is important for both the reviewer and the author. Clear communication is important for both parties. Being respectful and not making it about, not making it personal. That's important for both the author and the reviewer. Good communication, good respectful communication along the way. Again, you're both on the same page. Your goals are the same. right, there's one other person here. That's the manager here. And the manager actually has some things that they can do. One thing is that when you're assigning authors and reviewers, make sure that everybody is reviewing code. It's a good thing to spread that knowledge across all of your code authors. And so by making them a reviewer, that's one good way to address this bus/lottery problem. And also a good way to just disseminate information back to each of the reviewers, because everybody has, or each of the authors rather, because everybody has their own way of doing things. They all have their own area of expertise. Everybody knows something that somebody else doesn't know. Don't have the same person reviewing the same person's code over and over again. In other words, don't have Joe reviewing Jack's code always. Make sure that sometimes Joe is reviewing it, sometimes Jane is reviewing it, sometimes Joyce is reviewing it. Rotate them. If Joe and Jack have too close of a relationship, they may just automatically be, rubber stamping an approval on those code. That's not a good thing at all. And then you use the tools in your DevOps system. There's tools like Azure DevOps and GitHub that will allow you to force code reviews to happen, that they won't be able to merge anything into the main branch unless a reviewer. You can even set it up so that you can have multiple reviewers. You can have rules about that you must respond to every single one of the issues before you can check it in, before you can merge code, things like that. Use the tools that are in there to enforce this. And then foster a culture of teamwork. This is really important. There's a myth that somehow the reviewer and the author are adversaries, that they should be battling each other's, and I could not disagree with that more. That is not the case at all. They have a common goal. That goal is to improve the code base. They both want exactly the same thing. So if I'm writing code and somebody points out a problem with that code or a potential problem with the code, they are doing me a favor. They are helping me to do my job better, to make that code better. And that's what the manager should be doing. This idea of, let's penalize people if a reviewer finds bugs in their code, that's absurd. That fosters, that encourages the wrong behavior. And then also remember, code reviews are awesome, but they're not a silver bullet. They're not going to guarantee quality. There are still some things that you might be missed. You're all on the same team. I said this a couple times already. Communicate that as a manager. All right. I promise I've got a few more slides here with some links on them. But if you go to tinyurl.com/ I think this is case sensitive, this will take you to this slide deck here, or you can scan that barcode. That'll also take you to it. I'll hold that for a second before I go to the next slide. And here, a whole bunch of things right here, including if we go to my blog, I actually wrote a long article which covers all the stuff that I talked about in this presentation right here. That's on there. And then, oops, where am I? Right there. There I am. And then, like, most things that I know, I learned them from reading other people. And this is if you read all this stuff here, these are the things that ideas that I got from other people that have incorporated into this. You want to go dive deeper into that. There's all kinds of really good information in all these articles. One of these has the link to the idea of the prefixes, which I just absolutely love that idea, putting prefixes in front of that. Another one has the thing about praising code. All kinds of things in here. So let's see what else is in here. Oh, it's time for questions. Who's got questions?
Yeah. Okay. There are like.
Oh, before actually, I was going to show a quick demo here. I mentioned this, that if you go into Azure DevOps, here's a repo that I put in Azure DevOps. And if I go down to repos, where is it? Branches right here. Then this is kind of hard to find, but it's under branches. If I want to enforce this policy to say nobody can check into the main branch, then I put a policy on that branch. And this little third vertical dots here has branch policies is one of the things here. And this is where I can set up to say require reviewers. I can turn that on. I can even say require at least 2 reviewers here. And, you know, by default, you can't approve your own changes. You have to have somebody else do it, but you can allow that. You've got some things you can put in here for that. You can set other policies as well, but you can set all sorts of things here. Same thing in GitHub. Here's a repo. This repo actually contains the slides for all my presentations, including this one. Or I'm sorry, it doesn't contain the slide. It contains the abstracts of each one of those. And on this right here, there is under settings for a repo. Again, click branches, and you would add a branch protection rule right there. And in this case, you can say require a request before merging, and opening that up specifies some more options here as well that you can do. So this is where you can set it up ahead of time. And I would recommend doing that once you create a project, is put some limits, especially on the main branch. They used to call it the master branch, but the main branch, have those kind of policies in place. All right, now I'll go back to, where was I? Here. Have I lost it?
There was one question here, if you
There
can
we go.
see it on the screen.
There's a screen. Okay. Who should mark? Stefan asks, who should mark a review comment as completed? The author when implementing the feedback, or the reviewer when they're happy with the change explanation? And the answer is the author should mark it as completed. So in most of these ALM systems like GitHub and Azure DevOps, the author or the reviewer can create an issue or create a comment, and they can even tie it to pointed at a line of code. And the author can then respond to that comment, but to actually specify that it's completed, that's the reviewer spot. They're the gatekeepers. It's not completed until they say it's completed.
Perfect. Thank you.
Any other questions? All right, I got to say, I'm really happy to be here speaking in Pittsburgh, even though I'm not with you physically. I actually lived in Pittsburgh for about 3 months in the 1980s, and I lived up on Mount Washington, almost exact spot where Bala is showing right here between the 2 inclines on Grandview Avenue. And I had a great time when I was there. I still have some friends that live in Squirrel Hill, and I was out there visiting in December, and I actually went to a Steelers game and sat in the rain for 2 hours while they delayed just to watch them lose to the lowly Arizona Cardinals, which was a disappointment, but it was a lot of fun.
Thank you, Dave. It was a pleasure hosting you, and thanks everyone for joining us today. We'll see you next month with another exciting topic. Thanks, everyone.
Thanks, all. Bye-bye.